So we are live. Hi everyone, welcome back to Codera. Today is another session for mastering game theory for CodeForces rounds, live problem solving. So just let me know in the comments if I am audible to everyone. So just let me know in the comments and give a +1 so that we can begin ahead. Okay, hi Sethi. Hi. Okay, great. I'll just wait for a couple of minutes for other people to join in, and then immediately after that we'll begin ahead. So yesterday we had discussed two problems. Basically, there were three problems, right? But the third problem, that was I think matrix game. It in which the answer was either Vivek or it was Ashish. So that problem, talking about that problem. So that problem was uh, basically we had covered that problem while doing the greedy problems as well, right? So that is why we didn't cover that problem. And talking about the second problem. So was the second problem clear to everyone that in the second problem what we had to do was we had to just every time we had to just see that what is the minimum in each row, and then we had to check that what is the minimum in each of the n streets, and after that we had to choose that street which had the maximum minimum value. Okay, right? Is this much part clear to everyone? Just quickly tell me in the chat. I just wanted to know if this much part was clear to everyone or not. Was this much part clear to everyone? Right, everyone was clear with that? Just quickly tell me in the chat so that we can move ahead with today's session as well. I'll just be waiting for your replies so that we can begin ahead. Was the problem for yesterday, that was the second problem, dinner with Emma, was it clear to everyone that you had to, in each row you had to find the minimum, and then you had to select that row which had the maximum value of the minimums among the minimums, right? So that is how you would be choosing, right? Okay, so shall we begin ahead with today's session? Just quickly let me know in the chat if everything is clear. Then shall we begin ahead with today's session? Okay, great. Let's begin ahead with today's session. So we'll be discussing three problems. We'll try to discuss all of them because usually in game theory the concept part is something that we need to take some time on. Coding is very simple for game theory problems usually, and we'll be discussing this problem, which is sequential nim. It is rated as 1100. Okay, and we'll also be discussing this problem, which is ping pong. It is also rated as 1100. Then we'll also be discussing this problem, godsend, which is also rated as 1100. Okay, so these are the three problems that we'll be discussing today. If we do not have time, then we'll only be discussing two problems, but whatever we'll be discussing that in depth. So let us begin ahead with the problem statement. So the problem name is sequential nim, and it was asked in CodeForces round 658 division 2. So it says that there are n pillars of stones, where the ith pillar has ai stones, right? So there are n pillar of stones and the ith pair has ai stones, right? So let me draw it first. First of all, let me draw it. So there are n pillars, right? So there are n pillars and each has ai, right? Each has ai number of stones. Now what is given further? So two people play a game where they take alternate turns to remove the stones. So basically these people are taking alternate turns to remove the stones. In one move, one player may remove a positive number of stones from first non-empty pile, right? So the first non-empty pile, the pile with the minimum index that has at least one stone, the player will be removing at least one stone from that pile, right? And the first player who cannot make a move because all the piles will be empty will lose the game. If both of the players are playing optimally, then you have to determine who will be the winner. Okay, is this much part clear to everyone? Now us look at the test cases. So in the test case, what you will be given is, you will be given t test cases, and in each test case you will be given n, that is the number of piles, and then you will be given the ai value, right? And if the first player wins, then you have to print first. The player who makes the first move will win. For each test case, if the player who makes the first move will win, output first, and if the player who is making the second move, he wins, then you have to print second. Okay, so you have to determine the winner. Okay, right. So let's quickly copy the test cases and see what we can do with this problem. Okay, right, so this is copied. Now let me copy this part as well. Chalo, let's start. Right. Okay, so let's say you have been given n value as 3, and you have been given 2, then you have been given 5 and 4, right? So let's see if there is some understanding given for this pile, right? So for the first test case, this can be one of the strategies. The player 1 should take the stones from the first pile. He will take 1 stone, right? So they are saying that player 1 takes 1 stone. So player 1 starts and he takes 1 stone out of it. So now this 2 will become 1, right? After this, what will happen? The second player starts and he also takes the stone from the first pile. So he also takes 1 stone, right? So okay, he also takes 1 stone. Now this will become 0. Now what they are saying is that the first player should take the stones from the second pile, because the first pile is empty, right? So he will take 4 stones. So they are saying that the second player will now take 4 stones and left will be 1 stone, right? After that, the next player will come, right? The first player chance is done, second player comes, and this becomes 0, right? After this, what will happen? It will happen that the first player should take the stones from the third pile, because all the other piles are empty, right? So what will happen in this case? For this case, you can see that only there is 4 left, right? So the first player turns is there and he comes in and he takes all the 4, so it is left 0. So ultimately it is 0. And when the second player comes in, so in that case, what will happen? When the second player will come in, so he will not be able to pick anything, right? So second player loses and the first player will win for this case. Is everyone clear with this part? Just quickly tell me in the chat. Is everyone clear with this part? Is the test case clear to everyone? Just quickly tell me in the chat. Clear, okay. So how do you clear, right? Is it clear to everyone? I think it is, right? So what should be our approach? What should be the approach? How will you solve it, right? Both are playing optimally. Let's read the problem statement again if there is another information, right? So what will happen? It is given here, right? Both the players must be playing optimally, right? That would be perfect. But you have to determine who will be the winner. The first player who cannot make a move, player can pick any number of stones as per question. Yeah, right. He can pick any number of stones. It should be positive, right? He has to pick at least 1 stone if there is a stone present, right? In a move, a player may remove a positive number of stones from the first non-empty pile, and the player who cannot make a move will lose. Okay, both of them are playing optimally. You have to determine who will be the winner, and you will be always given the array, right? Let's say if you will be given this case, let's cover another test case for this problem. Okay, right. So if let's say I was given 8 times 1 1 1 1 1 1 1 1 1 1 1, right? If I was given this, so in this case, what will happen? First of all, the first player comes in and takes this. This will be for the first player. Then second player takes this one. First player again takes. Second player takes. First player, second player, first player, second player, right? When the first player comes again, so he will not find anything, right? So that is why he loses. So the second wins. Second player wins. player can pick, is this much part, is this test case clear to everyone? I think that this test case is also clear, right? Now let us look at the next test case. What will happen? Usually in such problems, you first of all need to look at the test cases, right? Let's say if you've been given 1, 2, 3, 4, 5 and 6. What will happen in this case? If you have this, right, what will happen? You can pick this, right? Let's say the player 1 picks this, right? So first player picks this up, the second player picks this up, the third player, the first player again picks this up, right? Then the fourth player picks this, not the fourth player, sorry, the second player again. So the second player again picks this up. Then what will happen? The first player picks this up, and then what will happen? The second player picks this up, and after that the first player will come in and he will not be able to find anything, right? So the second player wins, right? Right. How should we approach this problem? How should we approach this problem? Just quickly tell me in the chat. What do you think that should be the optimal approach for solving this problem? What do you think? Just let me know. Let me know your views on this. What do you think that we can do? There can be a lot of cases, right? If I say that we can take another case, so let's take another case for this problem, right? So if let's say I have this case which is 1, 2, 2, 1 and 1, right? If I have this case, in this case, what will I do? I can say that the first player can pick this one, second picks this one, first picks this one, second picks this one, first picks this one. So in this case, you will say that second should lose, first wins, but that will not be the case. Why? Because what will happen in this case is, let's say 1, let me write it again. Okay, let me just move down a little bit. Okay, okay, let's see this next test case. So if it is 1, 2, 2, 1 and 1, right? So we can say that first player picks this one up, then the second player just picks one, so second player just picks one, so the first player can pick this again. Then you can say that the second player picks this, then the first player picks this, right? The second player picks this complete, and then the first player picks this, second player picks this, so the first player will be left with nothing to pick, so that is why second wins, right? But how do you know that who will win? How do you know that who will win? Yeah, they will, it is not necessary that they will choose all from all the piles, right? It is not necessary. But how will you approach this? For this problem, for this you can see that first the second player picks just one from this, and for this second and first, and then second picked this whole, right? So that is what we did for this problem, right? So how should we approach this? What should be the approach for for us? Also notice that player 1 starts. This is important. Player 1 is starting. Player 1 starts the game. So is there anything dependent on him as well? How will you do this? This is a little bit tricky game theory problem. How do you think that we should do it? How do you think that we should do it? How do you think that we should do it? Can someone in the chat tell me? Does anyone get any idea like how we can approach this problem? Anyone has got any idea for this problem? How will you approach it? Anyone would like to tell me in the chat? Anyone can think what we should do for this one? Not getting any idea. Okay. Right. Not getting, sir. So what will you do in a contest? You will try to think, right? Let's try to think. Let's try to think a little bit. I'll try not to tell the answer myself. I'll try that we all come to a possible conclusion for this question. Okay. Let's do this. What will you do? Let's say you have been given 2, 5, and 4, right? What will you do in this case? What will you do? How will you choose? What will you do? Let's say player 1 picks this one up, player 2 picks this one up, player 3 picks this one up, right? If this is the case, so in that case what will you do? In that case what will you do? What will you do in that case? Is there any difference? There will be two types of pile, right? Let's see this. If there is 1 1 1 1 1, if there is situation like this, then you do not have a choice, right? If I say that my AI is equal to 1, then you have to choose it, right? Then you have to pick it completely, right? Because you have to pick at least one, right? You have to pick it completely. But if AI is greater than 1, right? If it is greater than 1, then you can pick one or more, right? Or I should say that you can pick all, you can pick all AI, you can pick complete AI, or just leave one in the pile, right? In the current ith pile, right? These can be the two possible scenarios, right? Is this part clear to everyone? Just quickly tell me in the chat. Quickly tell me in the chat. Is this part clear to everyone? Is this part clear to everyone? Quickly tell me in the chat. Just quickly tell me in the chat. Like, is this part clear to everyone? There can be these possible scenarios, right? Other than this, we don't think that there will be anything else, right? Okay. Right, let's move ahead. Let's try and think. If ith pile is having one only, then you have to pick it. If it's not one, then you can pick it or not pick it, right? So what does the answer actually depends on? What does the answer depends upon, right? How do we conclude that we have something with us? So what can happen? Let's try and pick. Okay, let's try and see what we can do for this problem. um let's say that if the number of piles that I'll be having, if let's say I have 1 2 3 4 5 and 6, if I have this pile, right? So in this case what will I do? What is the total count of piles, consecutive piles that are 1? So count of 1 piles is nothing but 1, right? Count of total consecutive 1 piles is 1. Everyone will agree to that, right? Everyone will agree to that. So this is the pile that is only 1, and other than this all the piles are greater than 1, right? Everyone will agree to that. Now what will happen? This pile is only 1, right? So what does this mean? What does this mean? This means that if I pick this pile, if I pick this pile up, then what will happen? If I pick this pile up, so the first player comes in and he'll pick this pile up, right? After this, after this after this you can see everything present here is present in this form, right? So what will happen in this case? Can someone tell? Can someone try to think of it? Can anyone try to think of this? Anyone can try to think of this. What will happen in such a situation? What will happen? Anyone? Anyone would like to tell us what should happen in this case? Just think about it. What should happen? What should happen in this case? What should happen in this case? Anyone? Or should I tell the answer? Okay, let me tell you. Let me tell you what we can do for this. Let's say that you have this pile, okay? So if your starting piles, if they are greater than one, right? If they are greater than one, if the starting piles, let's say there are some number of piles which are greater than one, right? Or let's say if there is a starting pile just a of one which is greater than one. So in that case, what you will do, if by removing this, if by doing this, if by doing this, if by doing this, if the player one wins, right? If if let's say what will happen, if there is some AI, some AI such that by removing it, if the player one is winning, so player one will definitely pick it completely, right? Otherwise player one will not pick it, right? Will leave exactly one stone. Why does this happen? Why does this happen? Okay, let me tell you a little bit about it. Let me tell you a little bit about it. Okay, let's say you have again 2, 5 and 4. Since you are having 2, 5 and 4, what you can do for this case is, if the player 1 picks this one, player 2 picks this one, then the player 3 will pick this one up, right? But how do you determine this? How do you determine this? How do you set a particular formula for yourself? So if there is this, and if by picking this completely, if the player 1 picks this one completely, right? So let's say if the player 1 picks this one completely, then player 2 will pick this one up, and again player 1 will pick this one up, right? Completely. Now you'll say that another situation can happen, that player 1 picks this one up completely, then player 2 can just leave one, so player 2 can pick 4 and leave 1. So in that case, what will happen, player 1 will again take, right, player 2, then player 1. After that 4 is left, player 2 comes in and player 2 will pick completely, right? So in that case you will be at a loss, because now you'll be at the losing end. How do you determine that when will be the situation when you win? Can anyone tell me? Any thought? Like this is a bit tough problem for all of you. No, sir. We have to think to make all ones first and see who picked the pile in the last, right? Okay. Okay. What should we do in this case? What should we do in this case? So what player one can do, if let's suppose that there is any pile, if let's suppose that there is any pile such that if player one, if there is any pile such that player one, if there is any pile which is greater than one, then player one, if player one picks this completely up, and then player one can win. So in that case player one will pick this completely up. If the player one loses by picking this one up, so that is why player one will not pick this one completely and he will just leave one, so that the second player picks this up, and then in that case he will be winning, right? That is what I am saying. Is this part clear to everyone? Is this much part clear to everyone? If there is a pile, let's say there is a pile, okay, let's say there is a pile, let's say that it is 2, then you have, let's say, 5 and 4 and again 2, right? If you have this pile, so first, if let's suppose that first one picks this one up, right? First player picks this one, second, first and second. So in this case player 1 is losing, right? In this case player 1 will lose. But when can be a situation when he will not lose? What he can do is he can just pick one pile of it. So he can first takes this chance, then second will take this, then first takes this one, second takes this one, first takes this one up completely, and first wins. First wins. Are you able to see this? Do you agree on this? That if player one picks this one up completely, if player one picks the first one up completely, then in that case player two, then in that case if he wins, so he will not pick, he will not he will pick the A1 completely, right? Otherwise he will not pick it completely. Everyone agrees on this? Just quickly tell me in the chat. Everyone agrees on this? Everyone agrees on this? And in that case, if let's suppose this was not the case, if let's suppose this was the case, 1, 2, 5 and 2, just think of it. So for this case, you can pick this one up. So first one has to pick this one up. He has no other choice. Second one picks this one up completely. Then first will pick this one up completely. Second picks this one up completely. And first loses. First loses. Is this part clear to everyone? Let me tell you one thing. Let me tell you one thing. Let me tell you one thing. Can I say that the answer depends on which player gets the first pile, such that for that pile AI is greater than 1? Can I say this? Can I say this? Does everyone agree on this? Just quickly tell me in the chat that AI is greater than 1. Can I say this? That the answer depends on the player who gets, on which player? The player who gets the first pile, which player which gets the first pile such that AI is greater than 1 for that pile. Only then he will be able to manipulate. Otherwise, if there are bunches of ones, then in that case no player can do anything. Answer depends on the player who is getting the first pile which is greater than 1, right? Everyone agrees on this. Just quickly tell me in the chat. Because if there are 1 and 1 and 1, all these things, then in that case no matter, right? Because you have to pick it. You have to pick it. Any player, either the first or the second, he has to pick it. But whichever the, let's suppose that there are a lot of ones, but there is a pile AI such that it is greater than 1, then the answer will depend on that pile. Answer depends on that pile. Now can you think of something? Can you think of something? Can you think of something now? Okay, let me take a case. Let's take a test case. Okay, let's take a case. Let's say that, let's try to take it in a bit simple manner. Let's say if I have 1 and then I have 2. Okay, if I have this case, so in this case player first has to pick this one up, second comes in and second picks this one up. So who wins? Second wins. Second wins. But if it was like this, 1, 2, 3, if this was the case, then what will happen? Then what will happen? What will happen? No, let's not take this case. Let's say this case, 1, 1 and 2. Let's say if this was the case, first player takes this up, second player takes this up, then first player takes this up completely, right? So the first player wins. Now let's think of another case. Let's say 1, 1, 1 and 5. First takes this one up, second takes this one up, first takes this one up, first has to take it, second takes this one up completely and second wins. Can you think of something? Now can you think of something? Can you think of something? Can you see a pattern here? Can you observe a pattern here? Depending on the ones, right? Answer is depending on the bunches of ones that are regularly. Answer depends on that. Whichever player gets the first pile, whichever player, right? Notice whichever player gets the first pile, which is non-zero, he wins, right? Whichever player gets the first pile which is greater than 1, he will win. Everyone will agree to that, right? So if k is the number of, let's say that these are the bunches, right? Let's say this is 1 only, this is 2, this is 3, right? So if the number of contiguous ones from the start is odd, is odd, then what will happen? If it is odd, then the second player wins. If the number of bunches, there is only one bunch, right? So that is why there are two bunch of contiguous ones from the start. So that is why first wins. There are three bunch of contiguous ones. That is why second wins, right? Everyone is clear with this part. Everyone is clear with this much part. Just quickly tell me in the chat. Only then I'll be able to move ahead. Is this much part clear to everyone? Just quickly tell me in the chat. Quickly tell me in the chat. Is everyone clear with this part? Now there can be two cases. Once more, can you explain? Yeah, sure. Bilkul, sure. I'll explain it once more. Let's try and see what we can do for this case. There can be two situations, right? There can be two situations. The first situation will be, there can be two situations, right? There can be two situations. The first situation can be that all are 1, right? All AI are 1, right? And in this case, at least one AI is greater than 1 in this case, right? So we have discussed this case. If I have just one, let's say I have just this one, then in that let's say I have 1 and 2, right? Or let's say if I have only one, so in that case the first player picks this one up and the first player wins, right? But let's not take this case. Let's take this case 1 and 2. In this case the first player picks this up, second picks this up. So if this is the case, at least one AI is such that it is greater than 1. In that case the second wins, right? Second wins. If this is 1 1 and 2, right? Or you can say 1 1 and 5. In this case what will happen? First player has to take this, second player has to take this. First comes in and he will take everything out. First wins, right? First wins. If 1 1 1 and 5, first second will come in and he will take everything because he wants to win, right? Is this part clear to everyone? That if there is at least one AI which is greater than 1, then in that case what you will do is, if there is at least one AI which is greater than 1, so in that case your answer will depend on the number of contiguous ones from the start. Whatever is the number of contiguous ones, if the number of contiguous ones from the start, if it is odd, right, if it is odd, then second wins, right? Second wins, second player wins. And if it is even, then first wins, right? Because everything is dependent on that, which the game will be played, game will be controlled by the player who is getting the first pile which is greater than 1, right? Is everyone clear with this part? Just quickly tell me in the chat. Is this part clear to everyone? When at least one AI is greater than 1, then your game will be controlled and won by the player who is the first to get to this pile which is greater than 1. Is this part clear to everyone for this case? Yes, got it. Okay, what about others? Just quickly tell me in the chat. What about others? Quickly tell me in the chat. Now we'll also be looking at this case. Okay sir, now understand perfectly, because player having to win, so he will pick all the piles after bunch of ones. Yeah, right. Because now he will control the game, because he is getting the pile which is greater than 1, so he can control the game. Because if he to win, if he has to pick everything from this current pile which is greater than 1, he will pick all, otherwise he'll not pick, and the game will be controlled by him, right? That we have discussed for all several test cases, right? But if all are ones, let's say these are ones, right? So in that case the answer is very simple. If there is only one, so first wins, right? First wins. If there are two ones, first and second, then second wins. If there are three ones, then in that case first will win. If there are four ones, then in that case second will win, right? Everyone is clear with this? Everyone is clear with this much part? Is everyone clear with this much part? Just quickly tell me in the chat. Quickly tell me in the chat. Is everyone clear with this? Your answer is ultimately, if there can be two situations only. One situation is that if all are one, then if the number of ones are odd, then in that case first will win. Otherwise if it is even, if there are all ones, and if it is even, if there are even number of ones, then the second will win, right? And similarly for this case, for the second case, when there is at least one AI which is greater than 1, so your answer depends on the first player who gets the pile which is greater than 1, because he will be controlling the game. The game will be controlled by him and he will win the game. Because if it is odd, then second will win, because second will be the first player who will be getting this non-empty pile. So he can shape the game, he can shape the pace of the game according to him. Either he can pick all, or he can just leave one, right? And that the game will be controlled by him, by the second player. Whichever player gets the first pile which is not empty, the game will be controlled by him. Everyone is clear with this? Just give a +1 in the chat if everyone is clear with this. Just quickly give a +1, please. Quickly, quite quickly, I want a +1 from everyone. Everyone is clear with this part? Everyone is clear with this which part? Just quickly tell me in the chat. Quickly tell me. Quickly tell me in the chat. Give a +1. Okay, everyone is clear with this part? Shall I code this part? Okay, let me code this out. Let's say this was our problem, right? Let me just increase the font size a little bit. What I just wanted to check the comments. Is this much part clear to everyone? Can you explain the test case 4, 1 and 2? Okay, let me explain you the case 4, 1 and 2 as well. That is good that you are thinking about test cases. Okay, so if let's say I take 4, 1 and 2, let me remove this part. Okay, let me remove this part. Let's see if I take 4, 1 and 2. Okay, if the 4, 1 and 2 case is there, 4, 1 and 2, so in this case what can you do? In this case, the first player will come in and he sees that if he picks this completely up, then the second player has to pick this up, and the first player picks this up, so the first player wins. First wins. So in this case, the number of ones is even, right? The number of ones from the beginning are even because it is 0. The number of starting ones is 0. That is why the first player will get the first element which is greater than 1, so he will be controlling the game. So that is why he will win, because he is the one who is controlling the flow of the game. Is this part clear to everyone? Is this test case clear to everyone? First, second and first, because first will see that if he picks this one up completely, if he picks 4 completely, then second will have to pick 1, and then first will have to first can pick these 2 completely, right? Is this clear to everyone? This was it in this game. Is this much part clear to everyone? Just quickly tell me in the chat. Quickly tell me. Is this clear to everyone? Shall I write the code for this? Shall I write the code for this problem? Just quickly tell me. Shall I write the code for this? Okay, it is clear, right? Whichever is the first player who gets the, yes, thank you. Great. It is great, right? Whichever player, basically the concept is that whichever player gets the first pile which is greater than 1, he will be controlling the game, right? Because according to that he can choose. He can choose according to that, right? I'll be having n and I, and let's say I have a count of ones that I'll be initializing to 0. I'll take n as an input, then I'll declare an array of a of n, right? After this, what I'll do is I'll take the input for I start from 0, I is less than n, and I plus plus, right? After this, I will take c in a of I, right? And what I'll do, I will, let's say I mark my I as 0 now, right? Or let's say I mark X as 0. What I'll do is I will say that while let's say that I write a condition according to this. Let's say I declare for int x starts from 0 and x will be less than n, and x a of xi a of x a of x should be equal to 1. If it is equal to 1, then my condition will always be true and I'll be moving ahead. Okay, what I'll be doing in this is I'll be counting, right? I'll be counting. Is everyone clear with this? What I'll be doing in this part? Let's not write in this manner. Let's say that I write in using a while loop. So x is this, and I'll write that while my x is less than n and my a of x is equal to 1. So I just keep on counting, right? I do an x plus plus, right? I do an x plus plus, and what should I do next? What should I do next? Let's say I have the count of ones. That I have the count of ones. What will I do next? If it happens that x is equal to n, if my x is equal to n, so that means that all were 1. If all of them are 1, so in that case what will happen? If all of them are 1, right? If x is equal to n, so in that case there will be two situations, right? Let's say you come to the end. So if in that case, if my x is what? If in that case, if all are 1, so that means that all the elements are 1. So in that case what will happen? Or if all are 1, then in that case answer depends on n. If n mod 2 is equal 1, right? So in that case first will win. In that case first will wins, right? Everyone will agree to this. And else I'll say that second wins, right? Everyone is clear with this? If it is odd, then first will win, because only there is one, right? If you do not come to the end, so that means what? If you do not come to the end, so that in that case what will you do? If you do not come to the end, if you don't come to the end, right? If you don't come to the end, in that case what will you do? If you don't come to the end, so that means that if your x mod 2, if your x mod 2 is equal to 1, so if it is odd, then what will happen? If it is odd, then who will win? Then the second player will win, right? Everyone agrees to this. Then the second player wins. Everyone is clear with this part? Just quickly tell me in the chat. Second wins, right? First wins. Second will win if n is odd. Otherwise x is odd, that is the number of elements. All depends on n. If all 1, yeah, right. Or if all 1, then it will be dependent on n. Otherwise it will be dependent on x, right? Everyone is clear with this much part? Just quickly tell me in the chat. Only then I'll be able to move ahead. Search for greater than 1. Yeah, right, but you don't need to do that. Why will you apply x will be ultimately pointing to that index only. That is why x will give you a count of that only, right? Let me just copy the samples and see if my problem works or not. Let's see if this works or not. Okay, so first, second, second, and first, right? Okay, let me copy this and see whether it will get accepted or not. This was a good problem, I would say. Also notice that it was a problem B. Let me submit this and see whether it works or not. I can see a lot of people are watching, so if you haven't liked the video, you can consider liking the video. Okay, it got accepted, right? It got accepted. Let me show you the code part once again. What I'm saying is, but I have to dry run once more by my own. After, sure, you should dry run. I take all inputs. After that, I will check if the total count, if I'm pointing to the end, that is if my x is pointing to n, I will check that if my x is less than n and my a of x is equal to 1, so in that case I'll keep on incrementing, right? And in the end I will check that if all the elements, if this means that all ai, all all elements are 1, right? All elements are 1, all elements are 1. If all elements are 1, then if the value of n is odd, then first will win, because let's say if it is 3, so first, second, first, right? If it is odd, then the last chance will be taken by first player and second player will not be able to make it, right? So that is why first will win. I can see some people are live. You can consider liking the video if you are liking the explanation. Else I will see out the second, I'll print the second one, because if n is even, so in that case who will win? If n is even, so in that case the second player will win, because first, let's say if n is equal to 2, so and there is 1 so there is 1 and 1, so first player will take this one, then the second player comes and takes the second one, so that is why the first player will not be able to take a move, so that is why second player will win. Now if that is not the case, so you will check that if x mod 2 is equal to 1, right? If x mod 2, that is if the number of ones that you have found up till now, if it is odd, if the number of ones is odd, so that means that the first player who will be getting, if it is odd, then that means that the first player has got the last chance with this odd one, right? If there are 3 ones and then there is 4, 5, anything, right? So first, second, first, right? Then the second player will get the pile such that ai is greater than 1, so he will win because he will be controlling the game. Otherwise the first player will control the game and he will win. Everyone is clear with this part? Is this question clear to everyone? Is this problem clear to everyone? Just quickly tell me in the chat. Just quickly tell me in the chat. Is this clear to everyone? Is this problem clear to everyone? Just quickly tell me in the chat. Is everyone clear with this problem? This problem definitely took some time, but it was a good problem, right? Okay, what about others? Just quickly comment down below. So if we will discuss another question, so it might take 40 to 50 minutes, so that is why it might exceed, okay? And if let's suppose that I did this question in 30 minutes, so you will observe one thing, that if I did this question in 30 minutes, so in that case what would have happened for this case is that you would have not been able to understand it better, right? But if I took some time, I gave you some time to think, so that is why you were able to think, right? You can think. You have to always think, if there are all ones, what if there are not ones? So you will, if you will run for some test cases, you will always observe that the first player who is getting the pile which is greater than 1, he will be winning, okay? एक ही रखें, ये सीख लें. Yeah, sure. So okay, so right, so this is the code. You can take a screenshot of this. This is the simplest way that I thought that this code can be written, right? Let me show you some more things. So what we did today was, we were able to just solve this problem, right? But the problem level was good. It was a problem B, and it was not so easy, but if you will not solve such questions, right, it was rated at somewhere around 1100, okay, rating. So for this problem the rating was this, and it was a problem B. So you can see that if you will not try to solve such questions, then how will you learn, right? How will you learn? So that is why you need to practice such questions, okay? Now telling further, so today we were able to discuss one problem only, because I was giving you time. From the next class what will happen, I'll give you some time before the lecture only, so that you can have a look at the problems itself. So from the next class I will be expecting that you read the problem and you have tried some approaches, right? So that we can discuss more problems. So let's meet tomorrow 5 p.m. Let's meet tomorrow. And what we'll be doing is, we'll be discussing more game theory problems. We'll be discussing game theory problems again. And what we'll be doing is, we'll be discussing first of all this problem. For tomorrow we'll be discussing first of all this problem. ping pong, this problem, and we'll also be discussing this problem which is godsend. Okay, ping pong and godsend, and if we have time then we'll definitely be discussing another problem as well. I can see 5 people are watching. Please give a +1. Please like the video if you haven't. Please like the video. I want the like counts to increase. Okay, right, perfect. So for today, I think that this much is it for today. Tomorrow we'll be discussing these two problems, that is ping pong and godsend. So what I'll be doing is, since I have some time, so let me take some questions. I'm here. You can ask some questions, okay? If you want, you can ask some questions regarding this channel or anything regarding CP or DSA, okay? You can ask some questions. I'll be taking some questions. So do you have any questions for today? From the next class, I'll be expecting that you do these two questions. Let me show you again. In the next class, you should be doing this question, ping pong. Don't say कि sir आपने link नहीं share किया. You can search this educational round 99 ping pong problem. Then you have this problem godsend. Try to think of these problems as much as possible. Ping pong and godsend. Okay. I will be taking some questions. So if you have any questions, you can ask, please. Does anyone have any questions? Any questions that you would like to ask? Let's do a quick Q&A. Any question that anyone would like to ask? So Subhajit, I think that this was your first live. Let's meet tomorrow and we'll be discussing more problems, okay? I think that no one has got any questions. So I'll just be waiting for 30 seconds more, if there is in case any question. Otherwise we'll be ending this stream for today. Okay? Okay, so let's meet tomorrow only. If you haven't liked the video, you can like the video. लीड कोड डेली आएगा, आ जाएगा लीड कोड. we are planning to, we will try to be regular with that. Okay, we will try to be regular with lead code daily. Basically we will try to upload it regularly. Okay, so CP में मैथ्स के लिए क्या करें, क्वेश्चन नहीं बनते. What you can do is, if you want to learn anything, you can learn from this website, that is CP algorithms. You can search for any topic and you can learn any maths topic theory part. You can learn it from CP algorithms or Geeks for Geeks. You can website. You can learn it from there. Okay. Also, you just need to have some command over GCD, prime numbers, then sieve of prime. After that, you can have some idea about let's say HCF as well. So these are some of the topics that if you have in mind, then you can do easily. Okay. Also we have a playlist on maths problems on Geeks for Geeks practice channel on GFG practice. If you will search GFG practice maths for CP, so there will be a playlist that will come on the internet and you can watch that. Okay, so we just need time. Peer pressure are too much. We just need time. Yeah, right. So let's meet tomorrow. Let us meet tomorrow and let's discuss more problems tomorrow. So tomorrow we'll be discussing the problem ping pong, and we'll also be discussing this problem, that is godsend. Okay, let me write it again. So there will be a problem C, that is ping pong, that we'll be discussing, and then I don't know why the writing is going this way. So we'll be discussing a problem that is ping pong, and we'll also be discussing a problem that is godsend. And if we have time, then we'll also discuss the third problem. Okay, this is what we'll do tomorrow. So let's meet tomorrow, right? Okay. Today we took some time, but that is okay. We'll learn more. Hope that this session was helpful. Okay. Thanks a lot everyone for tuning in. Let's meet tomorrow.